All right, today we're going to make some nylon from an amine and an acid, specifically a diamine and a diacid. My two reagents need to be dissolved in two different solvents. The first solvent I'm going to be using is cyclohexane, which is an organic, clear colorless solution, looks just like water. And my other solvent will be water. Of course, an aqueous and an organic solvent do not mix. So when I pour water and cyclohexane together, it immediately forms layers. That's going to be important. We now have an interface, and that interface is where the reaction is going to take place between my two reagents. So into my water, I am going to dissolve the amine. So just a little bit of distilled water and very little 1,6-hexadiamine. And 1,6-hexadiamine dissolves quite well in water. And will form a very basic solution. I'm going to put a little drop of universal indicator in there to indicate, yep, it's basic. It is a purple solution. That tells me it is significantly basic, as one would expect from an amine solution. In my second beaker, I am going to take, again, some cyclohexane solvent and put in a very little bit of sebacoyl chloride, which is an acid chloride. It dissolves well in the organic, and this will produce a very acidic, strongly acidic solution, as is indicated by the universal indicator turning red. When I pour the cyclohexane with the diacid into the amine, the cyclohexane layer stays on top. Where the two reagents mixed, we now have an interface, and we can pull out some of our nylon. Now, that's not how we want to do it. How we want to do it is to, right at the interface, grab some nylon and pull out a fiber. From the very little amine and acid that we put in, we can get quite a bit of nylon coming out. Okay, with one that I set up earlier without any dyes in it, so you can't see which is the acidic or basic one, let's see how the fiber works this time. And you can see the reaction is only taking place at the interface between the aqueous and the organic layer. As I slowly pull the fiber out, the reaction continues and we get a continuous fiber. And so we are making the textile nylon. Even from a very, very small amount of diamine and diacid, we can get a substantial amount of nylon fiber wrapped around my tweezers. And if we go very rapidly, we can pull it out. And there's your nylon fiber.